Hello everyone, welcome to Zoom in Data. In this AI 900 learning series, we will learn the fundamental concepts of artificial intelligence and explore Microsoft Azure AI services. This series is designed to help you understand the key concepts required for the AI 900 certification. Artificial intelligence enables computer systems to perform tasks that require capabilities such as learning, perception, prediction, reasoning, and language understanding. Machine learning is a major approach within AI that learns patterns from data to make predictions or decisions. AI includes capabilities such as computer vision, natural language processing, speech, and generative AI. Understanding these fundamental concepts provides the foundation for learning Azure AI services. Machine learning starts with historical data that contains examples relevant to the problem being solved. The data is prepared and provided to an algorithm that learns patterns and relationships during the training process. The trained model is evaluated using data that was not used to train it so that its ability to generalize can be measured. Once the model performs acceptably, it can be used to make predictions on new and previously unseen data. The three major learning approaches are supervised learning, unsupervised learning, and reinforcement learning. Supervised learning uses labeled examples to learn how input features relate to a known target value. Unsupervised learning works with unlabeled data to discover patterns, structures, or groups within the dataset. Reinforcement learning uses an agent, environment, actions, and rewards to learn behavior through interaction. Supervised learning trains a model using labeled data, where the expected output is already known. Classification predicts a category such as spam or not spam, while regression predicts a numerical value such as house price. The model learns a relationship between input features and the target variable during training. Supervised learning is commonly used for prediction, risk assessment, customer classification, forecasting, and fraud detection. Unsupervised learning works with data that does not have predefined target labels. The algorithm attempts to discover hidden patterns, relationships, or groups within the available data. Clustering is a common unsupervised learning technique that groups similar observations together. Unsupervised learning can support customer segmentation, anomaly exploration, pattern discovery, and exploratory data analysis. Features are the input variables that provide information to the machine learning model. A label is the known target, or outcome, that the model attempts to predict in supervised learning. For example, customer age, income, and purchase history can be features, while customer churn can be the label. Selecting relevant features and defining the correct target helps the model learn meaningful relationships from the training data. Machine learning datasets are commonly divided into training, validation, and testing portions depending on the modeling approach. Training data is used to learn the model parameters from examples. Validation data can be used to compare models and tune settings, while the test set provides an independent evaluation of the final model. Separating these datasets helps reduce the risk of evaluating a model only on information it has already seen. During training, the algorithm adjusts the model to reduce errors between its predictions and the expected outcomes when using supervised learning. Evaluation measures how well the trained model performs on data that represents the intended real-world use case. Classification can use metrics such as accuracy, precision, recall, and F1 score depending on the problem. Regression can use metrics, such as mean absolute error and root mean squared error, to measure prediction differences. Overfitting occurs when a model learns the training data too closely and performs poorly on new unseen data. Underfitting occurs when a model is too simple to capture the important patterns in the data. A good machine learning model should learn useful patterns while generalizing well to new observations. Appropriate data preparation, model selection, validation, and regularization techniques can help manage these problems. Azure Machine Learning is a cloud service designed to help organizations build, train, deploy, and manage machine learning models. It supports activities such as data preparation, model training, experiment tracking, deployment, and monitoring. Azure Machine Learning can support both code-based and low-code or automated machine learning workflows. Understanding the purpose of Azure Machine Learning is important for identifying the appropriate service in AI 900 scenarios. Machine learning enables systems to learn patterns from data and use those patterns to make predictions or decisions. Supervised learning uses labeled data, unsupervised learning discovers patterns in unlabeled data, and reinforcement learning learns through rewards and interaction. Features, labels, training, evaluation, overfitting, and model performance are fundamental machine learning concepts. Azure Machine Learning provides cloud capabilities for building, training, deploying, and managing. Thanks for watching this AI 900 learning video. For more learning content, tutorials, and real-time projects, stay connected with Zoom Data. Visit our website, subscribe to our YouTube channel, and follow us on Instagram. See you in the next video.